right, so if you're coming from the YouTube short for this one, you could probably skip this part right here, but for those of you that are just looking in, all right, so literal equations are essentially equations that just have more than one variable. Now, up until this point, you've really been solving equations, for the most part, that have only had one variable, so that's why these ones look weird, especially as you get a little more advanced in the problems that they ask. But we pretty much solve them exactly the same way when it was just one variable. And so just to go into a quick example before we go into more difficult ones, let's take a look at this one right here. So we have an equation with two variables and we need to solve for x. So I want to get rid of everything that's not x. So I see a minus 7y, so let's get rid of that. So opposite operation, add 7y, we have to do that to both sides, plus, and then we'll rewrite this. We have 4x equals 3 plus 7y. Now we're almost there. If you notice, that's a 7. If you notice, not even much better. We have to get rid of this 4, and then we'll have our x by itself. So 4 times x, we have to do the opposite, and we divide by 4. And we do that to both sides. And once we do that, now we have our x. And that's pretty much it for these. Now you'll come across problems. I don't think I have one written out where you'll end up with, let's say, this is our answer for this, but you might end up with a variable in the denominator. You're dividing by something. And your teacher may ask you something like, what are the excluded values or something like that. So in this case, this equation, just random, I just came up with it. If there was a b or whatever variable in the denominator, this only works if b is not 0. And that's because if you remember, when you first did fractions, denominator cannot be 0. Okay, so if you ever have an answer and you have a variable or multiple variables in the denominator, depends on, again, sometimes you don't have to write that, like, hey, this, b can't be 0 or something like that. It'll look like, b not equal to 0, or if they ask you, hey, what are the excluded values of insert whatever, that would be 0, right? Or if there was like a plus b or a times b, something like that. A and b, neither of those can be 0, something like that. I just want to put that in there. That's really the big distinction between literal equations and one variable equations. Okay, you might have a variable in the denominator, and depending on if you're doing excluded values, you want to make sure you put that, okay, this equation works as long as, blah, 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 can't be 0, okay, or whatever the value is. But anyway, went off track there. So this one, all that, and then we go with that. So let's take a look at a little more tricky one, in that I want you to know how to do this particular technique so you can save some time. So if you look, we have our Celsius to Fahrenheit equation, and we want to solve for Fahrenheit. I think I spelled this wrong, but it doesn't matter. So we want to solve for F. Now, you can distribute that 5/9 inside using the distributive property. That's perfectly fine. I want to show you the trick that I like to teach. And if you have, basically, it's if you have a fraction that's a coefficient, so a fraction coefficient, and you want to get rid of it, which we have to here, because our F is trapped inside these parentheses, multiply by the reciprocal. The reciprocal of a fraction is just, quite literally, just swap the top and the bottom. So we're going to multiply by that, and we have to do that on both sides. And the reason why this works is because 9 over 9, that cancels to 1. 5 over 5, that also cancels, and so those disappear. So if I were to rewrite this equation, I would now have 9/5 times c equals f minus 32. And now we just have our f minus 32, so there's one more step. So we add 32 to both sides, and if I was to rewrite that, I would have 9/5 times c plus 32 is equal to f. And this should be a capital F here. And that's it. So, and again, it's up to you. You don't have to use this reciprocal method. It can save you some time. I just don't like distributing fractions because they can kind of get ugly pretty quick, especially without a calculator. So that's pretty much all we have to do for that one. All right, so let's try one more. So for this one, pretty much the same idea. We want to, in this case, solve for y. So if you notice, again, the variable that we're trying to solve for is kind of stuck inside of parentheses. So again, if you're comfortable, I don't want you to think that you can't use the distributive property and then, now we don't have to worry about the parentheses. But I want you to be on the lookout or comfortable with, because at some point you will need to do this. I can't think off the top of my head what the case would be, but I want you to be comfortable knowing that it's just 3 times this whole thing. Well, let's just drop the 3, and then we don't have to worry about distributing that. So now I know, again, if there was like a +1 here, then we couldn't really do that. Well, we could, but it would just leave us with the fraction. So anyway, just showing you another way to do this. But so in this case, it's 3 times all that, so we need to do the opposite. So I'm going to divide by 3, And so our new equation looks something like this. Notice there's nothing multiplying this expression x minus y, so we can get rid of the parentheses. And now we want to solve for y. So it's up to you how you want to do this. I personally prefer to just get this y to the other side so we don't have to worry about that negative anymore. So I'm going to add y to both sides and subtract this z divided by 3. Now once I do that, add y, subtract z minus 3, then we have y equals x minus z divided by 3. And that's our y. And so again, same idea. I'm going to keep preaching, hey, like if you want to distribute, go ahead and distribute, because one, you need to know the distributive property of multiplication, but also as you get more comfortable doing that, I want you to notice like, well, wait a minute, there's an easier way in the future. This will be very convenient, especially when you have fractions and things like that. You don't want to have to distribute that if you don't need to. So that's it for this video. I made a part 2 that has 2 a little bit more advanced problems that you're definitely likely to see in class. One that has a little bit of factoring and one that is a word problem, which I know sounds like a lot of fun, but it's something that you'll definitely see from your teacher, or you may see it on a standardized test like the SAT or the ACT. So go ahead and check that out just to get a little bit more practice with these, and hope this video was helpful. This is Justin with Top Tier Math, and I'll see you in the next one.